All right, hi everybody. This question wants us to solve this equation. Let's take a quick look here though. Look at the domain here. It's from 0 to 2 pi. Now that's wonderful. That just means we're looking at solving this equation in the domain of a single full rotation. Now let's go to the equation here. 5 tan squared plus 2 tan equals 3. There's two levels to this problem. There's the algebra, or the quadratic part of this, and then there's the trig part. For right now, let's deal with the algebra. So what I'm going to do here is, I don't know what the tangent of theta is, so it's like an unknown to me. I might as well call it x. And by making that substitution here, I give myself the opportunity to deal with the algebra first, and I can deal with the trig later. So because this is a quadratic, I will bring the 3 over so that the function is equal to 0, or the equation is equal to 0, I should say. And then when I factor, I get 5x and x. And then what have I got here? This has got to be plus 1. This would have to be minus 3 to get the answer there. Good. So now in this case here, x is going to equal positive 3/5, or x is going to equal negative 1. Now we can go back to the trig. So that means either the tangent of theta was equal to 3/5, or the tangent of theta was equal to negative 1. Let's talk about this one first here. Tangent is positive, okay, in quadrants 1 and 3. Okay, so I'm going to get a first quadrant angle, and I'm going to get a third quadrant angle here. Now, what I need to do here is get my reference angle. Okay, now I don't recognize 3/5 from the unit circle or special triangles, so that means this is a calculator solution. Okay, and so now I will do the inverse tangent of 3/5. Now I'm in radian mode. Okay, so when I press enter here, I'm going to get my answer in radians. Now I'm going to identify, the question here says to the nearest tenth of a radian, so I'm going to identify my reference angle as 0.5. However, I'm not going to delete that from the calculator. I'm going to leave it like this. Okay, now in the first quadrant, that doesn't make any difference because the rotation angle in the first quadrant is the same as the reference angle, so that's going to be 0.5. But in the third quadrant, look at what we do here. To get into the third quadrant, I rotate, come around here to pi, and then I'm going an additional angle here, and that angle is my reference angle. So what I'm doing here is I go up to pi, and then I'm going to add my reference angle. But don't add 0.5. What I want you to do here is go to your calculator, and we're going to do pi plus that angle that we just found here. And I'm going to let the calculator do it this way so it uses as much of the decimal as it can. And this gets me 3.68, okay, so on and so forth. But I'm going to round that to the nearest tenth. So my answer is going to be 3.7. I'll just do it down here, 3.7. So my answers here from this factor here will be 0.5 and 3.7. Over here, in my second factor here, I see that my tangent ratio is -1. Well, tangent is negative in quadrants 2 and 4. My reference angle is going to be, and I can see this right away here, it's going to be pi over 4, but they want my answer to the nearest tenth. So I'm just going to go to my calculator here. And even though I can get the answer exactly, they want it to the nearest tenth. So I'm going to get that. And my answer here is to the nearest tenth is 0.8 for my reference angle. Now, in quadrant 2, okay, to get my angle in quadrant 2, what I do here is I overshoot it first to get to the x-axis. Now the reason I do this is when I'm measuring angles, when I'm using reference angles, it's always with respect to the x-axis. So the first thing I'm going to do is I'm going to overshoot this angle to get to the x-axis, and then I'm going to go backwards to it. This rotation is positive, this little rotation is negative. So how that works itself out here is this going to be positive pi, and then I'm going to add the negative rotation, the negative 0.8. Okay? Now, that means essentially what I'm going to do here is pi minus that answer. And I will get 2.35 and so on and so forth, but I'm going to round that to the nearest tenth. And again, notice I'm not really, even though when I wrote my answer I rounded it, I'm still using the full decimal, so I'm not really rounding until I get to the final step here, and that is going to be 2.4. Okay, whoops, I'm sorry, you can't even see that, 2.4. Now, to get into the fourth quadrant, what I do is I come all the way around, and again, I overshoot that angle to go to 2 pi, and then I come backwards the reference angle. So that's a positive 2 pi with a negative reference angle. Okay, so now what I'm going to do here is I want to pull that pi over 4 out again. And now I'll do 2 pi minus that reference angle, 5.49 and so on and so forth, but now I'm going to round it to the nearest tenth, 5.5. Okay, I can see on here that I've got 4 terminal arms crossing that domain, 4 points of intersection, 4 solutions, 0.5, 3.7, 2.4, 5.5.